Hi, welcome to IT 345, Human and Computer Interactions. This is going to be a great semester because we all use computers. And this course is about how we interact with computers. Now, as students, one of the ways we interact with computers is we use our keyboard, we use our mouse. We might be sophisticated and actually use a dragon uh, dictation system. I know that when I text on my phone, I don't text, I'm just too kludgy. I record everything and then I go in and edit it, or at least I usually try to, unless I press the wrong button and it sends it without it edited. But the whole point is how we react and interface with computers is changing. It is becoming so sophisticated. It is it is becoming like a thought combining type of activity where the computer is at some point there's a conceptual idea that the computer will be able to read thoughts and be able to react based upon thoughts. And we aren't there yet to the point that we would make that a commercial, but there are already experiments about that. So I start this whole class with the idea of universal design. And one of the big things that you as IT professional people need to know is when designing systems, you have to be thinking of, quote, universal design. That means designing for all sorts of people with all sorts of ethnicities, with all sorts of learning issues, physical limitations. We need to think big in order to design. So in this particular example here, what do we have? We have this runner, and she's wearing a Fitbit, some type of device, which is tracking information. It's tracking her heart, it's tracking the calories, it might be tracking the location that she's at, it's tracking all these things, it's populating it to some database. It's being used then by from decision support for who it might be used for, somebody who's doing evidence on the effects of running, somebody else who might be looking at how she's actually using her legs and her arms to be able to increase her speed. It might be used to be able to track her heartbeat. But all of this data is being captured just through this one device, through the action, the motion of her arms moving against her wrist. Universal design. So specifically, what is it? Well, if you do any web design, there's something called 508 compliance. And 508 compliance, if you need to know more about that, and if you're going to take any web design courses, is what? It is looking at how do you comply? How do you make sure that you're doing whatever you need to do to help people that are handicapped, visually impaired, audio impaired, and they're not necessarily people that are really just totally disabled. We have a growing number of seniors, and as if you're a marketer, you want to attract those seniors to your sites if you're selling things because they have more disposable income oftentimes. So it's being able to address the issues that impact others so that they can enjoy your site. So there are many different places to look at usability. The government has a website, and this website is all about usability. What makes a system usable? If you're going to do any work for the government, now it doesn't have to even be with a government agency. It could be just working for Marymount, any school that gets financial aid, which is almost every school, any organization that gets any kind of grant money, anybody who has a federal contract. All of these types of organizations must adhere to the 508 compliance and the usability structure as defined by usability.gov. And we'll get into that a little bit more later. But this is going to be a website that we're going to integrate into our course because this is what's really out there that people are having to follow. And my intent is to make you as current on what is necessary to be successful as possible. So this is one of those sites. These sites all talk about standards. They all talk about what are the minimum requirements you need to meet a group of standards. And the standards are all based upon trying to be inclusive of people of all different types, learning styles, physical limitations, etc. So when we think of human-computer interfaces, I briefly talked about it, but just to kind of show pictures of them, the mouse, the keyboard, the joystick, some of these are just so old. the light pen. Gesture computing is very big. I mean, we all probably use our mouse here or our pad to be able to, manipulate our cursor. The microphone is very big. Trackball, scanning information into your computer. And then these are some of the output devices that we see as well. But understanding how data gets into the computer is critical. And knowing that data is coming into the computer in multiple formats. A picture is what? A JPEG or a PNG file. A Word document is going to be either, depending upon the software, it could be a DOC, it could be a TXT, but it'll have a different file. An audio file will have an MP4. A video file could have a totally different file name as well. So you have all these different formats coming together to create like a mashup of different data types. And that's what we're looking at here when we think about data coming into our computer through different mechanisms with different file formats, and then thinking bigger, how do we present all of those on one palette? What good is it if every single time you have something come in and it's going to be a JPEG, you have to go to a certain screen to be able to only look at JPEGs? That'd be pretty annoying, wouldn't it? Okay, so what are the challenges? So when I think about the challenges of building the best system you can, looking at functionality, looking at best practices, there's three trade-offs that I always think about: time, money, and functionality or quality. In IT, those will be the three areas you will continually have to contend with. Time. The more functionality or the greater the quality you put into your system, it's either going to require one of two things: either more time from your existing staff or more money and bringing on more people to get it done quickly. If you have limited money, then you're going to be impacted by the amount of time something is going to take or the amount of quality you can give. And functionality, quality, that's impacted by both. So there's these trade-offs that you have to decide. And for user interaction, when you're trying to build systems, there's a rule of thumb that 80% of the functionality is usually achieved by, 20% of the budget. But it's that additional 20% of the functionality that you need that almost takes 80% of the budget. It's always that way. And knowing how do you build a system that's going to meet the requirements that you need to do, especially if you're going to be meeting 508 compliance, which is really the objective that we want to strive for from what we achieve in our classes here at Marymount. Making sure that we're as inclusive as possible in our designs and in our products that we produce. How do we do that within the constraints of time, money, and quality? So what are the benefits, though? Well, the benefits are that we have greater inclusion of people, A. B, we meet the 508 compliance issues because then we are able to work with government agencies, we're able to work as government contractors, we're able to work for education, anybody who receives government money, and that's almost everybody. So that's a big thing. And we're able to address a greater population of people. Some of the things that we have to be concerned about as we're building systems are, differences in culture, for example. How is date presented to different cultures? Some people it's month, day, year. Some people it's year, month, day. How do people read? Some people read from right to left. Hebrew, you read from left to right. What is the role of pictures? What is the bandwidth? If you're presenting information and you're going to a country where the bandwidth is very limited, a lot of video and a lot of visuals is going to be very difficult for people to view because it'll take too long for it to load because they don't have that bandwidth. So these are all the considerations we have to think about as we're doing our build. And looking at the interfaces that we have between the computer and between the human, looking at what are the future, because that's really what we're looking at. What are the futures? So I was reading an article just yesterday about augmented reality, visual augmented reality, and visual depth and those types of things. And they were talking about a couple of big uses. And at all of the new Six Flags, there's at least one particular ride, and it's just totally an augmented reality ride where you go up into the ride, virtual reality, you go up into the ride, and it's a roller coaster. And you're strapped into the seat and you're into this roller coaster, which is nothing more than a visual reality. And you think about it, how much less dangerous it is and how much less costly it is. Yet the satisfaction from the riders is significant, is very on par with those that actually go into the ride. Another one was somebody going into the ocean and swimming with shark. Very safe, but they felt like they were swimming with sharks. They wore these goggles, they were in a pool, but they felt like there were sharks all around them. That was another application. I recently went to Disney World and I rode this incredible ride, and it was a ride that took you on a spaceship shuttle up to the Mars or some place like that. I mean, that was just an amazing ride. You put on your goggles, you looked out, you saw the moon, you saw the craters, you felt like you were taking out some kind of propulsion moving you up in your seat. I mean, I got off that ride and I was like, whoa, I feel like I've been to the moon. So these are all the ways that we interact with computers. We take information in, and we benefit from the affordances of technology. So we will discuss them as we move through the class. So I look forward to having a great class with you. Thank you, and look to Canvas for all of the requirements for this week's lesson. Bye-bye.